Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 235. Please turn to it. Page number 235, and today is our lesson number 331. That problem that you see there on the top of page 235 is the exact same problem that appeared on the exact same page number in the first edition of the revised GRE. We have already solved every single math problem from this book. If you're interested in watching the original solution at a slower pace, you will find the original solution on day number 117. Here's what we're dealing with. We are given 2 points, point Q and point R. We are told that the coordinates of point Q are -2 and -3, -2, 1, 2, and -3. And the coordinates of point R, we are told, are 4 and 1.5. 1, 2, 3, 4, and 1.5 right there. And the question simply is, what's the distance from Q to R? What is the distance from Q to R? This distance right here. Let's call this distance D. Let's call it D for distance. And what is required here is what is known as the distance formula. Distance formula. However, what we're going to learn today is that distance formula is nothing new, nothing unique. It's simply a derivation of simple Pythagorean theorem. Distance formula is nothing but Pythagorean theorem incognito. It's simply a Pythagorean theorem in disguise, and we'll see that in a second. For example, in order for us to find this distance here, the first thing what we need to do here is to construct the triangle like we just did, a right angle triangle, and ask ourselves, very first thing we ask ourselves, what are the coordinates of this point? Let's give this point a name, Q, R, let's call it S. And the coordinates of this point are going to be, point S is going to have the same x coordinate as R, which is 4, and it's going to have the same y coordinate as Q, which is -3. Let's express the coordinates of these points in a more generic sense, in a more general way. Let's call the coordinates of point Q x1 and y1, and let's represent the coordinates of point R as x2 and y2. In that case, the x coordinate of point S is going to be the same as the x coordinate of point R, which is x2. And similarly, the y coordinate of point S is going to be the same as the y coordinate of point Q, which is -3 here, which is y1. Now ask ourselves, what is the distance? What's the distance from Q to S? The distance from Q to S is your x2 minus x1. x2 minus x1. That's the distance. x2 minus x1. And what's going to happen? What's going to happen is that because of the fact that x1 is negative here, so x2 minus a negative quantity, x2, which is 4, minus a -2, will actually become positive, which is just as well, because that's how much the distance is. The distance is 6 units. Distance from Q to S is 6 units, because distance from S to y-axis is 4 units, and distance from Q to y-axis is 2 units, so altogether it is 6 units, obviously. Similarly, the distance from S to R is going to be the distance from x-axis to R, which is 1.5, minus this distance here, -3, which is going to give us positive 4.5. That's all. And how do we express this? This thing is going to be expressed as y2 minus y1. y2 minus y1. So what happens? What happens? Our Pythagorean theorem tells us that the square of the hypotenuse, which we are representing here with distance d for the distance, our Pythagorean theorem tells us that d square has to equal the square of the other two sides. This side we just found out is x2 minus x1. This side here is right here, x2 minus x1. And this side we just found out is y2 minus y1. So x2 minus x1 squared, that's what the Pythagorean theorem tells us, doesn't it? Pythagorean theorem tells us that the square of the hypotenuse has to equal the square of the other two sides, the square of the sum of the other two sides. Or rather, not the square of the sum, but sum of the squares. The sum of the squares. So this square right here, x2 minus x1 squared, plus the square of the other quantity, which is y2 minus y1 squared. Well, that is your Pythagorean theorem. This here, what you're looking at, is Pythagorean theorem. But this is the distance formula. This is the so-called distance formula. A distance formula, I find it strange, I find it peculiar that the kids are asked to memorize it. They make a big fuss about it, but very rarely it's pointed out to them that distance formula is just Pythagorean theorem, incognito, in disguise. By the way, when did we learn about incognito in our vocabulary lesson? We learned the word incognito in our vocabulary lesson on day number 42. So if you're interested in improving your vocabulary, you can watch that video, vocabulary. Just type in GRE words, GRE vocabulary words, day 42, and you will see the video where we learned the word incognito, which just means in disguise. This what you here see is the distance formula, which, as we just saw, is simple Pythagorean theorem, which simply says the square of the hypotenuse has to equal the sum of the squares of the other two sides. Sum of the squares of the other side, which is x2 minus x1 square plus y2 minus y. That's it, we're done. Which is what we're going to apply here on the top. We're almost done. So our d square is going to be right here, 4 minus the negative 2 squared plus 1.5 minus a negative 3. Again, squared. Very good. There is your x2 minus x1 squared plus y2 minus y1 squared, which is your d squared. And therefore the distance that we're looking for, d squared, is going to be this quantity right here, which is 4 minus a negative 2. The negative and negative is going to be compositive. 4 minus a negative 2 is 6 squared, plus 1.5 and a 3 is going to give us 4.5 squared. That's it, we're almost done. How much is 4.5 squared? I don't know, let's find out. 4.5 is 45 times 45. 5 times 5. 5 times 5 is 25. 5 carry 2. 5 4s are 20 plus 2 is 22. 4 5s are 20, that's 0. Carry 2 and 16 plus 2 is 18. So it looks like it's 20.5. 4.5 squared is 20.5 and plus a 36. So we get 56.5. Our d squared is 56.25, and therefore our d is going to be square root of 56.25. And how much is the square root of 56.25? Well, that's a very simple, very straightforward answer to the question, which is how much is the square root of 56.25? The simple answer is, how the hell do I know? I don't know. We're going to have to use the calculator. Pick up your calculator and figure it out. But apparently the book tells us that it happens to be exactly 7.5. It happens to be exactly 7.5. And we can very quickly see why it happens to be exactly 7.5 by doing it out somewhere here. Let's do it here, 7.5. 75 times 75. 5 times 5 is 25. 5 carry 2. 7 5s are 35 plus 2 is 37. 7 5s are 35, 5, carry 3, 7 7s are 49, plus 3 is going to be 50, 52. So it gives 5, 12, carry 1, 6, there you go, 56.25 exactly. So it turns out that the book is right. 75 times 75, 75 times 75 is exactly 5,625, therefore 7.5 times 7.5 is going to be 56.25. The answer is 7.5. But of course in the real exam you're not going to be wasting our time like this. You just pick up your calculator. When I say pick it up, I mean do it on the screen. Just figure out the square root of 56.25. That's all. There is no other way. We're not going to sit there and waste our time. We do know that it's more than 7 because it's more than 49, and we know it's less than 8 because it's less than 64. So it's somewhere between 7 and 8, and if it had been a multiple choice question, and if there happens to be only one answer choice between 7 and 8, then you don't have to do anything. There is only one answer choice that you see there between 7 and 8, and that's got to be the answer. Because it's more than 49, and less than 64. Now exactly how much it is, I don't know. For that you have to pick up the calculator. I'll see you tomorrow, okay? Bye now.